Alright, so hello everyone. So in this video, what I want to do is I want to go ahead and sort of redo the video in where I did absolute value inequalities. I actually did one of them wrong, and um, yeah, I mean, I I messed up on one of them, and so I want to just make this video sort of um, to sort of, you know, correct my mistakes. So we're just looking at maybe about four examples. I'm going from easy to hard, so just so that I don't have to make multiple videos. So it says solve each inequality and graph your solution on the real number line and state your answer in interval notation and then check your solutions. Okay, so basically, we're going to go ahead and, and just look at numbers 1 through 4. So let me just go ahead and start. Let's start with the first one. So this first one says the absolute value of 5 minus 5x is greater than 10. So the first thing that, kind of, pops out at me is that we can factor this inside expression. So I can go ahead and rewrite this as the absolute value of the quantity 5 times the quantity 1 minus x. Absolute value is greater than 10. Now, there's a rule that says the absolute value of a times b, so times b, is really the absolute value of a times the absolute value of b. Okay, so if I make this b, I'm gonna have the absolute value of 5 times the absolute value of 1 minus x is greater than 10. So I know that the absolute value of 5 is just 5, so I can say 5 times the absolute value of 1 minus x is greater than 10. And then from there, what I can do is I can go ahead and divide both sides by 5. So I have something like this, and I get 1 minus x is greater than 2. Now, this gives me two things. So this is 1 minus x is greater than 2, or 1 minus x is less than negative 2. So really, when you have an expression x minus h, absolute value is greater than, let's say, b, then that means that the absolute value of x minus h is greater than, or I'm sorry, it means that that x minus h is greater than b, or x minus h is less than negative b, right? So we're just going to do, that's basically the rule that I'm doing here, right? So, and I forgot to put absolute values right here. So this gives me these two things. So now we're just going to solve for x. So we have, I'm going to move this to the other side. So I'm going to say 1 is greater than x plus 2. If I flip that around, I mean that x plus 2 is less than 1, right? So then if I subtract 2 on both sides, I get that x is less than negative 1, right? So this would be my answer for that. And then here, I'm going to do the same thing. I'm going to move my x to the right side, and I'll say that 1 is less than x minus 2. And again, I'll just say that x minus 2 is greater than 1. So then I add 2 to both sides, and I go ahead and say x is greater than 3. Now, what you want to make sure and do is you want to check your solution, okay? So when we have something like this, we want to look at both solutions, right? And we want to follow what to plug in for x. So for example, I have x is less than -1. So I'm going to say check x is less than -1. I'm going to pick a number that is less than -1. So I'm going to say, what about x is equal to, or let me do it this way. What if I say x is equal to -2? So if I plug that in for x, I'm going to say 5 minus the absolute value of 5 minus 5 times -2. Absolute value is greater than 10. So this gives me 5 plus 10. Absolute value is greater than 10. This gives me absolute value of 15. It's greater than 10, so then 15 is greater than 10. So it does satisfy the solution, or the inequality. So then what I'm going to do, give me a second, guys, sorry. So what I'm going to do next is I'm going to go ahead and get, so if I do, hold on, so we know that satisfies that one. And then I'm going to say, what about x is greater than 3, right? So when I do x is greater than 3, I'm going to have, so I'm going to pick a number that is greater than 3. So check x is greater than 3, right? So I'm going to pick a number. I'm going to say, what about x is equal to 4, right? And I'm going to do the same thing that I did. So I'm going to write my absolute value equation. I'm going to say 5 minus 5, x, right, is greater than 10. So I'm going to say 5, the absolute value of 5 minus 5 times 4 is greater than 10. So then I'll say the absolute value of 5 minus 20 is greater than 10. That gives me the absolute value of -15 is greater than 10, and the absolute value, and that'll be 15 is greater than 10, right? You can pick another number. If we did, for example, if we did x is equal to 5, can do minus 5 times 5, right? And then, that'll give me the absolute value of 5 minus 25 is greater than 10. So then I get the absolute value of -20 is greater than 10. So then 20 would be greater than 10. So it would still satisfy that inequality. Now, that means that my inequality for this is going to be x is less than -1 or x is greater than 3. So when I graph it, so if I do graph it, hold on. If I say let's go from -3, -2, -1. Let me do it this way. Let me do -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay. So, I have x is less than -1, right? So I'm going to go ahead and just put a open circle at -1, so right here. And I'm going to shade all the numbers that are less than -1. And then I'm going to pick x is greater than 3, so I'm going to put an open circle at 3 and shade all the numbers that are greater than 3. Now in interval notation, this would be from -infinity to -3, -infinity to -1, parentheses, union, and then it'll be from 3 to infinity. Okay, so this is how you would write it in interval notation, right? And if they want the answer in inequality form, this would be the answer, right? So that is how you do this first one, guys. I know it took a little bit long, but yeah. Okay, so this is the second problem that we're working on. So we have 10 times the absolute value of 6 minus 4x is less than 100. So the first thing that I'm going to do here, I'm going to go ahead and divide by 10, okay? So that's the first step, divide both sides by 10, okay? And when I do that, I get the absolute value of 6 minus 4x is less than 10. Now I'm going to go ahead and separate. I'm going to go ahead and factor the left side. So, I mean, you can just, actually, you can go ahead and just make this into two separate things. So you can say 6 minus 4x is less than 10, or 6 minus 4x is greater than negative 10. And then just solve it that way. You can also factor it, but you just have to be careful with how, just like I did up here, you can factor it as well. But you have to be careful with how to do that, just like I did over here. But you can also do it this way, if this way is easier. So when I go ahead and solve these two inequalities, I get, so I'm going to subtract 6 on both sides, right? And then I get negative 4x is less than 4. And then I'm going to go ahead and divide by negative 4. And I'm going to get x is greater than negative 1. So when you divide by a negative, you always switch the inequality. X is greater than negative 1. And then on this one, I'm going to go ahead and subtract 6 on both sides. And I get negative 4x is greater than negative 16. And then I'm going to divide both sides by negative 4. And I'm going to switch the inequality symbol. So I'm going to say x is less than 4. So if you think about it, we know that negative 1 is less than x, and we know that x is less than 4. So we can say negative 1 is less than x is less than 4. If that's something you don't understand, you can literally just graph both of these inequalities and you will see exactly what I mean. If we check them, we're going to go ahead and check them because there's always a possibility of them not, there's always a possibility of there being either all real solutions or no solution. So I'm going to go ahead and check these two. So I'm going to check, first I'm going to check x is greater than 1 or greater than negative 1. So I'm going to pick a number that is greater than negative 1. I'll say x equals 0, right? So when I plug it in, I get 10. So let me do it a different color. Do x equals 0. So then when I plug it in, I'll have 10 times the absolute value of 6 minus 4 times 0 is less than 100. Okay. So then I'll say 10 times the absolute value of 6 minus 0 is less than 100. So then I'm going to go ahead and say 10 times the absolute value of 6 is less than 100. I have 10 times 6 is less than 100, which is 60 less than 100, which is true. So this works. X is greater than negative 1 works. Now if I pick something that's less than 4, I'm going to go ahead and do that. So now I'm gonna check this one. X is less than 4, right? So I'm gonna pick, I'll pick x is equal to 3, right? So I'm gonna do check x is less than 4, and I'll do x is equal to 3. So when I do that, I get 10 times the absolute value of 6 minus 4 times 3 is less than 100. So then this will give me 10 times the absolute value of 6 minus 12 is less than 100. And then I'm going to go ahead and say 10 times the absolute value of negative 6 is less than 100. I get 10 times 6 is less than 100. So then 60 is less than 100. And that is the answer for that one, right? So, so really, you know, it would be x is greater than -1 and x is less than 4. So give me 1 second. Okay, so those two inequality, or this inequality, these two inequalities work, right? So this is how you would write it in, you know, in terms of the interval, right? So in interval notation, it would be from -1 to 4. And the way that you would graph this is you would, again, you would make a number line. So let me go from negative, let's do -6 to 6. So I'm going to do -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and 6. Okay, so I'm going to draw this number line, and the way that this is going to work is I have from -1 to 4. So I have, this is -1, and over here is 4, right? And all you have to do is just shade the numbers in between, right? So that is how you would write it. Now this is how you would write it in, or that's how you would graph it on the number line. And then this is how you would write it in interval notation, okay? So that is how you would do that one. So yeah. Okay, so this is the next example that we have. So for this one, the way that we would do this one, now we have something like this. So it's going to be, let me just rewrite it, -10x minus 2 is over 7 is greater than or equal to -3. And what you're going to do first is we're going to go ahead and multiply by 7 on both sides to get rid of that fraction, right? So then we have the absolute value of -10x minus 2 is greater than or equal to -21, right? You only switch the inequality symbol if you're multiplying or dividing by a negative number, okay? So let's see. So then this is going to give me two things. So the way that this would work is I'm going to, you know, we would go ahead and say -10x minus 2 is greater than or equal to -21, or -10x minus 2 is less than or equal to -21. Or I'm sorry, less than or equal to 21, excuse me. Okay, so then we're going to go ahead and, you know, solve both of these for x, right? So we have -10x is greater than or equal to -19. And then we're going to divide both sides by -10. And we're going to get x is less than or equal to, because we're going to switch the inequality symbol, and we're going to get 19 over 10, right? And I believe that's like 1.9. So x is less than or equal to 1.9. And then over here, we're going to go ahead and do the same thing that we did. So we're just going to do +2 on both sides. And we have -10x is less than or equal to 23. And then divide both sides by -10. And then we're going to go ahead and we're going to switch the inequality symbol again because it's by a negative number, right? So we're going to get x is greater than or equal to negative 2.3, right? So again, you want to make sure to check your solutions to make sure that they satisfy this inequality. Now, notice that we have a less than or equal to and a greater than or equal to. I'm going to go ahead and check x is equal to x is equal to 1.9, and I'm going to plug this into this inequality. So I'm going to do the absolute value of negative 10 times 1.9, and then minus 2 all over 7, and I'm going to do is greater than or equal to negative 3, right? Because it's less than or equal to, we have to make sure that this, both things are true, right? So when I do that, I get, I believe this is 19 minus 2. It's going to be 19 minus 2 all over 7. Actually, it'll be negative 19 minus 2. Negative 19 minus 2 all over 7 is greater than or equal to negative 3. And then I'm going to say negative 20, the absolute value of negative 21 over 7 is greater than or equal to negative 3. So then I get the absolute value of actually, I'm sorry. I get 21 over 7 is greater than or equal to negative 3. And I get 3 is greater than or equal to negative 3, which is true, right? So that satisfies that, right? Now, what if I pick something that is less than 1.9? If I pick x is equal to 1, right? So now I'm going to pick something that's less than 1.9. So I'm going to pick x is equal to 1, right? So I'm going to do the same thing. So negative 10, absolute value of negative 10 times 1 minus 2 all over 7 is greater than or equal to negative 3, right? So, so then I'm going to get the absolute value of negative 10 minus 2 all over 7 is greater than or equal to negative 3. So then I get the absolute value of negative 12 over 7 is greater than or equal to negative 3. And then I'm going to get 12 over 7 is greater than or equal to negative 3. Obviously, this is a positive number and this is a negative number. So, I mean, it's true, right? This satisfies that inequality, right? So I can say for sure that x can be less than or equal to 1.9. Now I'm going to do x is greater than or equal to negative 2.3. So again, I'm going to go ahead and do the exact same thing. I'm first going to make it equal to negative 2.3. So if I check x equals negative 2.3, I'm going to go ahead and do that. So I'm going to get, it's going to be negative 10. So absolute value of negative 10 times negative 2.3. And then, minus 2 all over 7 is greater than or equal to negative 3, right? So this would be 23 minus 2 all over 7 is greater than or equal to negative 3. This is 21 absolute value over 7 is greater than or equal to negative 3. This is 3 is greater than or equal to negative 3. So this works, right? So we know that negative 2.3 does work. Now, what about something that's greater than that? So we can pick negative 1. So if I pick negative 1, check x equals negative 1. I'm just going to do it like this. And I'm going to write the equation again. So absolute value of negative 10 times negative 1 minus 2 all over 7 is greater than or equal to negative 3. So I'm going to get the absolute value of 10 minus 2 all over 7 is greater than or equal to negative 3. I'm going to get absolute value of 8 over 7 is greater than or equal to negative 3. And I get 8 over 7 is greater than or equal to negative 3. Obviously, 8 over 7 is a positive number, and negative 3 is a negative number. So this satisfies the inequality, right? So given this, given these, these things, I can clearly say that this is true and this is true. Now the way that I can write this is negative 2.3 is less than or equal to x is less than or equal to 1.9. Because if you flip this over, you can say negative 2.3 less than or equal to x. And we know that x is less than or equal to 1.9, so you can add that in there. And now, to graph it, give me 1 second. Okay, so the interval that we're going to graph, we have this interval here, and we obviously know that in interval notation, that's going to be bracket negative 2.3, comma 1.9, bracket, right? So, obviously, we're going to put a closed dot at negative 2.3, and we're going to put a closed dot at 1.9, just like over here. And all you have to do is just shade in between those two endpoints. And this will give you the, this is how you would graph it on the real number line, right? So that is how you do this problem, guys, okay? Okay, so this is the last problem of this video, guys. I know this video was a little bit long, but this is the last one that we're going to do. So we have negative 2 minus the absolute value of 6 plus 3x is greater than or equal to negative 20. So the way that I'm going to do this, so again, we're going to go ahead and add 2 to both sides, right? So we have negative the absolute value of 6 plus 3x is greater than or equal to negative 18. And then we're going to go ahead and divide both sides by negative 1. Okay, so when we do that, we get the absolute value of 6 plus 3x is less than or equal to 18. And then finally, what you're going to do is we're going to go ahead and put the two things that we would make this equal to. So we have 6 plus 3x is less than or equal to 18, or 6 minus 3x, or I'm sorry, 6 plus 3x is greater than or equal to 18. We do that because, obviously, there's a rule, right? And if you guys don't know that rule, I would, really recommend that you look it up. But basically, you make it less than or equal to or greater than or equal to the positive or negative number. It's supposed to be negative 18. Okay, so then we get minus 6 here. So we're going to do minus 6 on both sides. Get 3x is less than or equal to, it's going to be 12. And then we're going to divide both sides by 3, and we get that x is less than or equal to 4. Okay, so that's one of them. And now the other one, we're going to do minus 6 on both sides again, and then we get 3x is greater than or equal to negative 24, and then we're going to go ahead and divide both sides by 3 again. And we're going to get x is greater than or equal to negative 8. Okay, so again, we can write this as the following way, right? And again, I would recommend that you guys, that we check it, right? So we're going to go ahead and do that. So when I say less than or equal to 4, I'm going to first check x equals 4, right? So let me go ahead and do that. So I have x is equal to 4, right? When I put 4 in, I'm going to get negative 2 minus the absolute value of 6 plus 3 times 4 is greater than or equal to negative 20. And then I'm going to go ahead and add, so I'm going to go ahead and do negative 2 minus absolute value of 6 plus 12 is greater than or equal to negative 20. Okay, and then from there, I'm going to get negative 2 minus the absolute value of 18 is greater than or equal to negative 20, and then I get negative 2 minus 18 is greater than or equal to negative 20. Negative 20 is greater than or equal to negative 20, so that does satisfy that inequality. Well, actually, it satisfies that part. Now we're going to do a number that is less than 4, so we're going to do x is equal to 3, right? So when I do that, I get negative 2 minus the absolute value of 6 plus 3 times 3 is greater than or equal to negative 20, okay? So then this becomes negative 2 minus the absolute value of 6 plus 9 is greater than or equal to negative 20. And we get negative 2 minus the absolute value of 15 is greater than or equal to negative 20. I get negative 2 minus 15, and yeah, like this. And then I get it's greater than or equal to negative 20. I get negative 17 is greater than or equal to negative 20, which is true, right? So this works. So we can clearly say that x is less than negative, or x is less than 4 works. Less than or equal to 4, excuse me. And then finally, we're going to check x is greater than or equal to negative 8. So we're going to check x equals negative 8 first. So check x equals negative 8. And we're going to do negative 2. So we have negative 2 minus the absolute value of 6 plus 3 times negative 8. So let me do times negative 8. And then greater than or equal to negative 20. So we get negative 2 minus the absolute value of 6 minus 24 is greater than or equal to negative 20. And then I'll get negative 2 minus the absolute value, and it's going to be 23, 22, 21, 20, 19, 18. So minus the absolute value of negative 18 is greater than or equal to negative 20. And then I'll do negative 2 minus 18 is greater than or equal to negative 20. Negative 20 is greater than or equal to negative 20, which is true, right? Now, when we go ahead and do, now we're going to go ahead and do something that's greater than negative 8. So we're going to do check x equals, and we're going to do negative 7. So when we do negative 7, negative 2 minus the absolute value of 6 plus 3 times negative 7 is greater than or equal to negative 20. So when we simplify this, we get negative 2 minus the absolute value of 6 minus 21 is greater than or equal to negative 20. So then that would be, I think it's negative 2 minus the absolute value of negative 15 is greater than or equal to negative 20. And then we get negative 2 minus 15 is greater than or equal to negative 20, which is negative 17, greater than or equal to negative 20. So that works, right? So we can clearly say that these two inequalities work. Now, the way that you would write it again is you can write this as the following: negative 8 less than or equal to x. And we know that x is less than or equal to 4, so we can rewrite this as negative 8 less than or equal to x less than or equal to 4. Okay. So then the way that we would graph this we would go ahead and just let me go from negative 10 to 5. So let me just go ahead and do this off camera. Okay guys, so we're gonna go ahead and do so we have negative 10, or I'm sorry, negative 8 less than or equal to x less than or equal to 4. So I'm going to put a closed dot at negative 8, and I'm going to put a closed dot at 4. And I'm going to shade all the numbers that are between those two parts, so right here. And then my answer in interval notation would be from bracket negative 8 to 4, close bracket. So that is how you do these problems, guys. I know this was a really long video and I do apologize, but that is how you do these problems. If you guys have any questions whatsoever, please do let me know, and also please like, comment, and or subscribe. And thank you so much for watching, guys, and I will see you guys in the next video. Bye, guys.